Our topic we are going to do today is on pendulums.
The pendulum was studied for the first time by Galileo, who discovered one of the most important characteristics, the pendulum isochronism. Galileo discovered this property, observing that the pendulum does not change its period, even if its amplitude decreases. This behavior depends only on the constant of gravity and the pendulum length, not its amplitude.
Period. Period is the time it takes for one cycle or motion, one oscillation. In an equation, the symbol for period is t. T is measured in seconds.
Frequency. Frequency is the number of oscillations per unit of time. Gravity. Gravity is the force that attracts a body towards the center of the Earth or towards any other physical body having mass. Gravity is represented by G and is measured in newtons.
The equation used for pendulum is T equals 2 times pi times the square root of L over G, where T equals period, L equals distance, and G equals acceleration due to gravity. If there is not enough information to plug into this equation, the equation T equals 1 over F can be used instead to find the period.
A tire swing has a period of 2.5 seconds. How long is the swing here on Earth?
The picture you see here is a tree with the tire swing. The arrow is representing the pull of gravity.
In this equation, we are given that period is equal to 2.5 seconds, and since it states that the swing is on Earth, acceleration due to gravity is equal to 9.8 meters per second squared.
This is the equation we have to use. We must plug in the variables. So for period, we have 2.5 seconds equals 2 pi times the square root of L over 9.8 meters per second squared. So first, we do the 2 times pi. So 2.5 seconds equals 6.28 times the square root of L over 9.8. So we have to isolate the square root first. So we divide 6.28 on both sides. And we have 0.398 equals the square root of L over 9.8. To take off the square root sign, we have to square it on both sides, which would equal 0.158 equals L over 9.8. To find L, we have to multiply 9.8 times 0.158, and L equals 1.553 meters.
If the tire swing was taken to Mars, where gravity is 1.6 meters per second squared, what would be the new period? We know from the previous question that the length is equal to 1.553 meters, and we are given that the gravity on Mars is 1.6 meters per second squared.
T equals 2 times pi times the square root, which root of 1.553 1.6 meters per second square. T equals, since we multiply 2 times pi, we got 6.28 times the square root of 0.958. T equals 6.28. We take the square root of 0.958 and we get 0.978, and we'll multiply 6.28 times 0.978 and then we get 6.14 seconds, which is our new period.